Hi, welcome to the first ever episode of Out of the Blue. It's going to be math and science with me, Blue. It's good to be here and thank you for watching. First of all, I've never done anything like this before, so I'm going to give you a little background on myself. I'm a student at UT Austin. My current major is mathematics, which is really awesome. This coming semester, I'm declaring a double major in astronomy. I can't wait to change the world, hopefully, someday. That's kind of why I'm doing this. I'm hoping to be a public figure someday in math and science. So thanks for watching this. Thanks for supporting me in some weird way. Today's first episode, we're going to be talking about really basic math that you're probably going to be like, oh god, why is she talking about that? It's going to be the Pythagorean Theorem. And I know that's like boring, you know what it is, and you don't want to hear it again, a squared plus b squared equals c squared. But it really is awesome, and I really want to talk about where it comes from and why it is what it is. So, just give me a second. Here we have triangle. It's a right triangle, as you can tell. There's a right angle on this side. This leg and this leg are A and B. The hypotenuse, the longest side of the triangle, is C. Now, we all know from the Pythagorean Theorem, which we've memorized many times, this square plus this square equals this square. And that's it. That's what we need to know. It helps us with a lot of stuff. But I'm going to give you guys a little bit of a demonstration to show you why exactly that works and how Pythagoras came up with it. So here I have an old science board, but more importantly than that, I have a square made of arranging four congruent right triangles in this specific pattern. Because of the way I arranged it, there's this big empty square in the middle, and this square's area is equal to c squared. We know that because each of the sides of the square is equal to c, because that's the hypotenuse of the right triangle. Now, I can move these triangles around any way I want in the middle of this square, and whatever's left over on the outside is still going to be equal to c squared. Here's a little example of that. I've moved this triangle in the middle of the space, but because the area of the outside square hasn't changed, because I haven't changed it at all, because the area of the four triangles haven't changed, because I haven't changed it at all, the area of all the empty space around it has to be the same, because nothing else has changed. So if I added up all these little sections of empty space, it would all add up to c squared, just like it did before. Now I'm going to do something that's kind of neat, and it's going to prove the Pythagorean Theorem to you. Here's our final arrangement, the grand product that tells us why the Pythagorean Theorem works. So I've arranged the same triangles in the same square so that the outside empty space is still going to be the same, it's still going to be c squared. But the way I've arranged it, you can see that this square is made up of the a sides of the triangles, the smaller leg, and this square is made up of the b sides of the triangles, the longer leg. Because of that, this square has to have an area of a squared, and this square has to have an area of b squared. Now, because of what I showed you before, we know that this a squared plus this b squared has to be equal to c squared. So and that's the Pythagorean Theorem, that's the proof, that's why it works, that's probably how Pythagoras came up with it. I'm not sure, I wasn't there. But you might be wondering why I'm doing this, because we all know a squared plus b squared equals c squared. It's almost robotic. We have it memorized, we have it down, we can use it on tests, we can use it in other subjects. It's fine, we know it. Why bother knowing where it comes from? And I don't think that's the right attitude to have. I think knowing where something comes from really helps you learn it. And I think if a lot of kids knew where the Pythagorean Theorem came from when they were learning it, it might help a few of them not get so discouraged from math. And I think that's a big problem in the world right now, is people hate math, and I don't understand. When I tell people my major is math, they freak out sometimes, and they're like, wow, good for you, I could never do that, or wow, you must be some sort of genius. And I'm really not. I'm just interested in a subject that everyone else seems to hate. I'm not sure why that is. Maybe it's because of stuff like this, where people don't know where the theories come from or where the equations and the formulas come from. And I think if we knew where things came from, we wouldn't be so dismissive of math. And I think math is at the basis of basically all the other science, so we shouldn't be so quick to dismiss it. On that note, I'm going to be back probably next week, so if you have any suggestions on videos that I should do, or anything that you've always known to be true but don't quite know where it came from, just leave it in the comments. If I can answer it, I will totally do that. I love doing this. It's great being here. Thank you so much for watching this video. It means a lot to me. and I'll see you later.